Hello, here's Peter Swiggle, Mr. C, your Earth Science teacher, and this is a short recording for Lab 108, a lab about modeling Earth science processes. There is a presentation to it, the first slide I have up here, that we'll cover during the Class Connect session. So here I just want to show you what you need to do to make those graphs, and so that you can have some direction there. If you want to know the why we do certain things in this lab, you need to watch the Class Connect session. That will be on the list of recordings, or you're attending a live session. Okay, close this one. So the lab report here has 5 parts. Part 1 is we're going to calculate the density of each rock model. The rock model at one of them is a conglomerate of rocks and ice, and the second one is a simple model. It's just ice, pure ice, and I'm going to give you all the data. Just want to give you an overview, and you're going to write down here which one is denser, more dense, has the higher density. I just want to give you an overview here again. Then you're going to write a hypothesis for the melting curve. That is, you know, if we expose these rock models to higher temperature, more than freezing, it will melt. So the conglomerate and the ice will melt, like ice cubes do. Describe the shape. What do you think? The shape of the mass versus time of these graphs. And which rock model will melt earlier? Which one will be basically melting earlier? Will it be the ice cube or will it be the conglomerate? And it's a big ice cube. And I want you to write this hypothesis before you look even at the data. You will not do any real experiment. The data will be given to you. It's already poking out here at the back as an Excel spreadsheet. Then you graph the data. I will help you with that today. We're going to graph it. We're going to create the melting curve of the conglomerate and the melting curve of the ice. That is important. And then number 5, I want you to describe the shape of the curves, which model, and answer which model melted earlier. And then also look back to your hypothesis. Would you change your hypothesis and why? About 5 sentences, well, plenty information to make 5 sentences. And number 5 is your extra credit opportunity. I want you to create, and I'll show you that also here, a graph that shows both relative melting curves and describe the graph. So we're going to create one graph with 2 lines there, one representing the conglomerate, the other one representing the ice. And the relative means we're going to look at percentages of the initial mass and compare the graphs using 3 or more sentences below. So let me look at that's all the lab there is. You type it in here and submit it and hopefully get maximum points. So here's your data sheet. So you do not have to do the experiment. Actually, at the end of the lesson, you're going to see the video of how this data was collected. So someone did this for us. They measured the mass of the conglomerate, they measured the volume, and we need to calculate the density. And I'm using Excel here. I assume all of you have access to Excel. Google Sheets works also, and others, but this is probably the easiest for you. So you're going to have that data. How do you going to then calculate the density? Sorry about that. We need to divide the mass here by the volume. And yes, you can do it in the calculator and type it in here, but we have the calculator here. It's a spreadsheet. So we put our pointer into the cell. I'm currently highlighting E4 here. You also see it up here. And all you're going to do is up here, we're going to type equals, and we're going to use the mass. I click over here. It's the C4 divided by the cell D4. So E4 will be the ratio of C4 over D4, and we're going to press enter. Boom. And it's there. It's actually calculated way too accurate than we need it. So we have what's called 3 significant figures here. So we're going to change them back. There's this button up here. You can change it to like this, 1.86 grams per cubic centimeter. And you can either do the same thing for the plane model, or you can grab this handle down here, and drag it down, and it will just do the same calculation. Shouldn't take us too much surprise that the density of water is about 1 gram per cubic centimeter. One cubic centimeter is 1 milliliter, so that's what we expect, right? The density of water is about 1. But we definitely heavier on the conglomerate. So we have a mixture there of rocks that are even heavier and water that is 1, and the mixture gives us a 1.86 gram per cubic centimeters. We could even calculate the fractions of it, but that's way too advanced. So this is one part. You would just grab that table here, highlight it, right click, say copy, and then you go to your lab. Now here you can paste it below. I hope you see where it's blinking currently. Let's make an enter here, and I paste it. Control V does the job, and I do it another way too. Instead of pressing Control V, you do a right click and say paste here. Paste. Keep source formatting. It's all there. You could even delete then this table. In order to delete table, it's best you click on the upper right. It highlights everything, and then this comes up here and say delete table. I let you do the rest, right? You need to decide and write me a nice answer here, which is part of these 5 points. The rest of you I wanted to show you. So now we need to create mass versus time curves for the 2 materials, and we go back here, and down here are tabs. They are called worksheets. One says conglomerate, and here's your table. There's time in minutes, and there's the mass in gram, and I scroll down one time, it goes all the way to 130 minutes. And not surprising, you look at the mass of it. So at the beginning we had the conglomerate of 420 grams, 0.4 kilograms, or about not 2 pounds, a little bit less. It starts out like that, it sits there, and then it starts losing weight, right? So we know it's going to go down all the way to 0. Okay, that's cool. Just to look at the next material, it's ice. It starts, we only had 210 grams there at 0, and it never increases. It doesn't make sense to increase, right? It just melts and all the way down to 0. Okay, 150. You could have stopped at 145. All right. You can look already at the data here and say at what time the materials melted away, right? Here it was at 145 minutes, and the conglomerate was at 130 minutes, right? We're not exactly sure, somewhere out between 125 and 130, but it was gone. So you can answer one question already by just looking at this data, which one melted faster, right? You can look at get this answer right away, but we need to graph it. So let's start with the conglomerate. The way to graph things is we need to select the data. So you click here at B2 and hold down your mouse. I'm going to select all the data. It's going to be a gray box here. Hope you can see that, and I hope I'm not clicking somewhere else. The first field is never, so it's never highlighted. So everything that's gray we selected. Then you go to Insert, and we go to this here. I'm going to choose Scatter. Very important. Don't use line graphs or anything else like bars or whatnot. We're going to use a scatter graph, and let's connect the dots here with something. We'll just connect the dots here. All right, I'm going to get this graph here. Let me increase it a little bit. Now, in other science classes, they go through that, and it's called chart candy. Don't go for chart candy. This is when you start playing with these things up here, like making it black and stuff like that. We not want to beautify it. We are in science, you know, it's not business. We're going to do it plain simple, okay? We have the graph here, and it's nice. It shows us mass in grams. That's what the title here was, but there's something missing here. The labels for the axis. So you can click here the plus sign. There, click it wrong. I'm sorry. I'm going to activate the graph, so now it has these handles on there, and it shows up here to the left. It's a add chart element. So we want to add titles to the primary horizontal. We want to add a title. We want to add a title also to the primary vertical. So then you click on these titles, and this is going to be your x-axis. X-axis. I don't need to format it anything fancy, but I probably should say here time and write in minutes, right? And I probably have something to say on the y-axis, right? This is mass in grams. Usually use parentheses around it, and the title could be mass versus time for conglomerate. You have to do this. I'm going to look carefully if you use my graph. So this is basically what we're looking for. On the y-axis is the mass, on the x-axis is the time. It's scaled appropriately. We can even estimate, it was stopping at 130. And it definitely, if you have doubts if this is straight or not, you can insert I'm looking for a box to draw something. Oh, illustrations? No. Add-ins. Home. Usually I find it more quickly. I want to insert a line. Page is not formula data review, maybe. No. Home. I want to insert a line. Insert elements. No, illustration. Shapes. Yeah, I was looking for shapes. Here it is. If you're in doubt whether this is straight or not, you try to find the shapes. It was under illustrations, shapes. Here's a line. You click here and down there, and I don't think it's that straight, right? And it has a certain shape. You can describe that, right? It probably starts out melting. There's nothing going on here for the first 15 minutes, and then it starts melting and it goes faster, 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 and then at the end it becomes kind of linear, right? That you could make a point, but that's your shape. And you're going to do the same thing for ice. You're going to do the same thing. The only difference will be up here. It will say for ice, right? That's our other Earth model, and that's not a bad model if you think about a cryosphere, right? Which is out of ice, and it's melting. So you're going to do the same thing there. At the end, you're going to grab the graph. I selected it. I clicked into it. I do a right click here, say copy. And we're going to go back to our Word document. And I made two spaces down here. One is for figure 1, the melting curve of the conglomerate. The second one is the melting curve of ice. So we're going to have these figure captions are always below the figure. So I just click here for now and press Ctrl V, and it's going to be a bit too big. So you click on these handles and make it smaller. Okay, that's good enough. Now, if you want to keep it big, because you have done such a good job in showing all the details, you can keep it big and breaking this title over for the second curve, and then see. There's a little bit of formatting. You can play around, but don't spend too much time on the formatting part, right? So now we have up here the melting curve of the conglomerate, and you have some space here for the melting curve of ice. You're going to paste that there.